Okay, I'm gonna go ahead and unmute everybody. And voila. I'm recording this just so y'all know. I posted it. So I might have to mute people if there's a lot of feedback. I'll do that. So a couple things. I just got the second monitor. I'm real happy about that. So this screen is not cluttered. Of course, I have to look up there now, but just to make sure everyone's aware of the expectations, we're going to have 2 sessions per week. Ours is going to be Tuesday, Friday. Each session, we're going to have a warm-up, and then we're going to have homework. So we're going to have 2 warm-ups, 2 homeworks per week. You do that, picture, send it to me through the Gmail. Okay, you do all that, you get a C. All right, we're going to have 2 assessments, and this is how we're going to do the assessments. And I got this, I was speaking with Mr. Walker about how to do this, so this is what we came up with. So I'm going to put you guys into different email groups, and on the day of the assessment, I'm going to email the assessment to you. So it's going to be just like a quiz, maybe a little longer, but just like a quiz. And so on the day of the assessment, I'm going to put y'all in different email groups. Y'all will get emailed the quiz, and you'll have an hour to finish it, take a picture, and send it back to me. All right. Now, I'm not anticipating these taking more than a half an hour. But of course, I can be flexible. You know, it's not going to be a hard, fast hour as far as that goes. All right. I'm going to go unmute y'all. All right. Anybody want to ask me anything about that?
Do you know when you're planning on, I guess, giving this assessment? Is it more of like a final, I guess? Like,
no, it's not really a final. It's kind of like what I would have done during this unit is I would have given you quizzes and then a test. So at the very least, I'm just going to give you the quizzes that I would have normally given you.
oh, okay.
So there's no final. Okay, so my understanding in the district protocols is that we're only supposed to give you guys 2 assessments.
Okay.
Okay, I appreciate you asking that because you might not be the only one. And so I'm allowing someone named Shu just joined us. So I'm gonna go ahead and go over the warm-up here. Now the difference here is that not only we're gonna get the domain, but we're also gonna get the range. Now, as we go through this, we'll see that we can get the range by using the domain, all right? And that's gonna be very helpful. Well, so here's our trig function, and just to remind everybody, you maybe remember, this 5, that's the amplitude, right? So we're gonna go up 5, down 5, so 5 and -5. There's no vertical displacement, so the middle is gonna be at 0. And remember, this 2, that's the K number. We call that the frequency. And so that means that we're gonna get 2 cycles from 0 to 2 pi, right? Now, we'll go ahead and make this graph so we can kind of use it to relate to what we're going to do when we get the inverse and find the range and domain. All right, so you can factor out the 2. So you'd factor out your 2, right? And then now notice that when this equals 0, it's pi over 6. So the phase shift is pi over 6, right? And if we wanted to get the period, the width of 1 cycle, right? We already know there's 2 going to occur between 0 and 2 pi. If we want to specifically get that period, we would just divide 2 pi by 2. Again, there's a couple, right? So pi is the period. Okay, so on this little graph here, 1, 2, 3, 4, 5, this would be pi over 6. And this would be 7 pi over 6. And then we bounce between 5 and -5, right? Make sure, review that. So we can see what the range is already, right? We know the range is going to be between 5 and -5, right? And the domain is going to consist of all possible angular values in radians, and so all real numbers. So for our function here, the domain is going to consist of all the x's such that the x's are all real numbers. Now, I'm not putting the braces here just to not clutter up this diagram, but you know, if you want to be a little more mathematically precise, you don't necessarily need that. Okay, and then the range is going to consist of all the y's so that we're going to be greater than or equal to -5, less than or equal to 5. All right. Okay, now let's go ahead and get the inverse. So again, just as before when we were looking at this, we solve this for y in terms of x, right? So divide by 5. Okay, now once we get to here, you can't divide by COS, right? That's function notation. Those COS are not variables, right? And so what we have now is we have the input to the cosine function, which is going to be in radians. I write pi there. Just loving that pi. So here the x would be in radians. So the input to the cosine function outputs an angle. All right. As I say, sorry, outputs a ratio which is multiplied by 5. Right. Okay. So we want to reverse this. That's what the inverse does. So when we reverse this, we switch the input and output. So we're going to go ahead and take the inverse of the other side. And we get this. So that's how you switch it to the inverse when you solve the inverse function of this cosine original function. All right, now it's just a matter of going to add pi over 3 and then multiply 1/2. So I'm going to kind of save a couple steps here because I don't have a lot of room. All right, so I'm going to add pi over 3, multiply 1/2. So this is going to become pi over 6 after we multiply the 1/2. And I'm just going to go ahead and switch it to the x here. Again, because when we represent the inverse with function notation, we want to use the same input variable as the original function. That way we can compare these two. All right, so here's our inverse. Now, to think about the range and domain. Okay, now there's going to be an easier way to do this, but let's save that for the second way of looking at it. First way of looking at it. Well, this is the inverse, and so we know in here is going to be a ratio. So the x now is the ratio, which came from the y of the function, right? Now, what about the output? So when we do this calculation, that's going to get us all the possible angles that have this ratio. And then, you know, as you remember, when we do the significant, what is it? Shoot, the words significant values, the principal values. So yeah, when we get the principal values, we're only going to get one. We're going to have to construct all the other angles known in trigonometry, right? So this is going to be an angle, which was the original x, right? So the range of the inverse is related to the domain of the function. And the domain of the inverse is related to the range of the function. So what's the domain here? Well, that was based upon the ratios, and we got that from the range of the function, right? And what's the range of the inverse? Yeah. Well, that would be the angles, right? Which was the domain of the function. Oh, sorry, right, y. Okay. So long story short, you can use the domain of the function to get the range of the inverse, and the domain of the inverse to get the range of the function. That's very helpful, because oftentimes the domains are easier to find. And it's the range that's a little bit more demanding. Now with trig functions, that's not quite the case, because you know we know how to graph the trig function cosine, so we know in between 5 and -5. Okay? Everybody good? I had to mute y'all because of the feedback. All right, I'm gonna go on to the next one. Okay, so the next one was a rational function, so the b function. And so we got a 2x minus 7 over a 4 plus 5x. which is something we can also graph, right? So we got our b function, which was a 2x minus 7 over a 4 plus 5x. Okay? Well, if we graph this thing, again, I'm using the graph because it kind of helps see the relationship of the inverse and the functions. All right, so that's a rational function. And remember, the vertical asymptote is based on the denominator. So when that's equal to 0, subtract 4, divide by 5. So that's going to be right about here. Okay, and remember, the horizontal asymptote is when you have the coefficients of the largest terms. So 2 over 5, right? So 2 over 5 would be the horizontal asymptote. All right, and what's the y-intercept? Well, if you replace x with 0, you get negative 7 over 4. Let me let Kyle back in. Okay, so if you find the y-intercept, you place that, you get negative 7 over 4, which is right here. So we can sketch this graph just by knowing the y-intercept. So that's the graph. All right, so what's the domain and range of this function? Well, the domain consists of all possible x values except the vertical asymptote x value, which is negative 4 over 5. So the domain here will be x such that x cannot be negative 4 over 5. Now we can assume all real numbers. So if you don't want to make that assumption, or maybe if you shouldn't make that assumption, then you can just put a little comma and say all real numbers. So this means the domain consists of all x values such that x is not equal to negative 4/5, given that x is a real number. All right, and then the range. Well, what's the range? Well, that's the horizontal asymptote. Okay? And so all values of y except 2 over 5, the horizontal asymptote. So the range consists of all y values such that y does not equal to 2 over 5. Now, for some rational functions that are more complicated, when you have polynomials that have exponents larger than 1, you might be able to cross the horizontal asymptote, but this one isn't that complicated. Okay, well, that's helpful. Let's go ahead and find the inverse. So going ahead and doing what we've been doing in the past, and now going ahead and cross multiplying. So 4y plus 5xy, and then 2x minus 7. Okay, so I'm going to do, again, what I call a switcheroo. So what are we trying to do here? We're trying to solve for x, because we want x to become the dependent variable, right? That's what inverses do. They switch the role of independent and dependent. So we want to solve for x. So we want to get x on the same side. Okay? So I'm going to do a switcheroo. I'm going to switch those. So I'm going to add 7 to both sides. I'm going to subtract 5xy to both sides. And again, basically, if you move it to the other side, you change the sign. So that's the switcheroo property. Okay, so now we want to go ahead and find x. So on this side, we have the x's by themselves. There's no x on the left. So we factor out the x. And now we'll have something to divide by. So now we're going to divide by 2 minus 5y. So I'm going to kind of skip a step here and just go to the function notation. So the inverse function is going to be, instead of x, is going to be instead of y, it's going to be 4x plus 7. We're dividing by this, 2 minus 5x. Okay? All right, let me let Crystal back in. Okay, sorry about that, Crystal. This is much easier to deal with. I might not have caught that as quickly. Okay, so now the point here is we got our inverse. Now notice how this relates to the function. All right, well, if we're looking for the domain, that would be the vertical asymptote. That would be 2 minus 5x equals 0, 2/5, right? The range of the function, domain of the inverse. right? Okay, well, what about the range? All right, well, the range would be the horizontal asymptote, which would be the coefficients of the largest terms, so 4 over -5. Well, look, that's the domain of the function. So domain of the function, range the inverse. All right. So again, we did this a little longer just because I'm trying to point out the relationship, but you can use the domain and range of the function to get the domain and range of the inverse. And then if you can find the domains of the function and inverse, you can use them to get the ranges. So that's very helpful. Okay, anybody want to ask anything about that? I'm looking at the chat because I had to mute y'all. The feedback was troubling. I'll unmute y'all once I go over the warm-up. Okay, so let's look at the next one, the last one. So the last one was quadratic. Okay, and so the last one was the quadratic, which would be the C function, right? So sorry about that. This is tough. 4x squared plus 12x minus 5. All right, so our quadratic, 4x squared plus 12x minus 5. All right, so the C function, 4x squared plus 12x minus 5. All right, now we're going to just go ahead and do this and get to the graph later. So if we're going to find the inverse here, we want to solve for x. Okay, so I'm going to add 5. Okay, now just automatically put this function notation as a y. Now I know some of y'all like to factor out your 4. I'm going to go ahead and just divide by 4. Okay, so then here is where we want to complete the square, right? So we need to take half of the 3. So we want to create our binomial squared problem. So that's what we want to create. Okay, well, what are we going to have to add to both sides to create that? All right. Right, so 9 over 4. So we add 9 over 4 to both sides. And then that creates our binomial squared. Right, so here we got a common denominator, so that's cool. And so when we add, we're going to have 9 plus 5 on top, which is 14. And then here's our binomial squared. Okay, and now we want to go ahead and take the square root, and then we're going to subtract 3 over 2. So I'm going to do 2 steps at once. Again, I don't have a lot of room here. All right, so take the square root and then subtract 3 over 2. All right, so note again, plus or minus, because if you're taking the square root in the process of solving or rearranging a problem, okay? And now notice something about this. In our binomial squared, when this is 0, you get negative 3 over 2. Okay, well, that's the x at the vertex. So our vertex is somewhere at negative 3 over 2. Well, what about the y at the vertex? Notice when this equals 0, because the domain has to be positive or 0, right? So when this equals 0, x is negative 14. That means that's the vertex. Negative 3 over 2, negative 14. Right? And then the inverse would be this one. Okay? And so the plus square root would be on top, the minus square root would be on bottom. All right, so what's the domain and range? Well, before I get to that, notice we could get the vertex here too, right? Negative b over 2a, negative 12 over 2 times 4, negative 12 over 8, simplifies. Okay? Well, x can be any real number, so the domain of the function, all real numbers. The range of the function, based upon the vertex, everything's got to be greater than or equal to negative 14. All right, well, the domain of the inverse. Well, the domain of the inverse is going to be related to the range of the function. Notice that that means the x's have got to be greater than or equal to negative 14. Oh, wait, what did I just say? Oh, yeah, okay, right. Sorry, y'all. I got tripped up. And then the range. Okay? All right, I'm going to unmute y'all.
Good, how you doing?
Okay, everybody good with that? All right, I'm going to go ahead and share a screen, and we'll look at the homework. All right, so which homework problems y'all want me to go over? Any particular one you want me to go over? Okay, number 7. Okay, I'll go through 7 through 14. That's probably going to be an issue. 19, okay. 26 and 17. 21, 23. 37. Okay, we'll go with that. Let me know. We only have one thing that we have to do today. It's not too demanding. Okay, so this first part here is asking for a percentage, but how it's asking the percentage depends upon the time units. All right, so this first part here was worded a little awkward, but it said the annual and compounding period are given. That means they give you the annual percentage and they tell you the new period of time. Okay, that's what compounding period means. And so it says find I, the interest rate per compounding period. Now, the thing about this stuff is they use these letters all the time. So I, R, they get thrown around a lot. So let's just go based on the wording. So we want to find, for number 7, what the percentage is per month if the percentage per year is 12. So that's why we divide by 12, 1%. 8, we want the percentage per quarter if the percentage per year is 11. So that's why we divide by 4. I think that's 2.75. 9, we want the percentage to be per half year if it's 7% per year. So we divide by 2, 3.5. And then here it's already 9% per year. So we want to find it per year. It's already 9%. Now 11 to 14 is the other way around. 11 to 14, they give us the rate per compounding period, and they want us to find the annual rate. Okay, so that 0.01 is per month, which means 1%. So it would be 12% for the year, right? This 2.5% is per half year. So it'd be 5% per year. 13 is already per year. 14 is per quarter. So to get it per year, we multiply by 4. So 14, 9% per year. Okay, and then 17. Now 17, this is 9% per year, and you want to compound it annually, which means for 17, you don't have to change the percent at all because it's already per year, and they want you to compound it per year. So whatever the time period of the rate is, that's the same as the exponent. So the exponent's based upon years if the rate is based upon years. And so then you just multiply 1.09 to 500. Okay, and then 19 800 is borrowed, so the principal's 800, just like 500 for 17. Now we're compounding this daily, so that means we're going to have to divide the 0.12 by 365, okay? And so when we do that for 19, this is our rate now. The exponent is going to be based upon days. Now don't get so caught up in a formula and think, oh, NT. I got to do something with N. I got to do something with T. If you're given time in years, then you can multiply to the years. But we're not given time in years for this problem. We're given time in days. All right, so they already give us the exponent. All right, so if our rate is based upon days, our exponent is based upon days. So that's why the exponent's 200. Okay, and then let's see, so I'm racing as I go. So we got 21, 23, 26, and then 37. Okay, so 21. Now this time you're looking for the principal, right? And so 6 months is the time. You want the percentage to be per month, so you can divide the 0.10 by 12. All right, so for 21 here, you can see this equals 100 now. You're looking for the P. So you do the 0.10 divided by 12, that create your growth factor. And now we have the exponent in months. So you don't have to multiply NT because they give you the exponent. All right, and then you just find what this is and then divide that by 100, right? Okay, I got 25. Okay, I got it, y'all. The second monitor really helps. So when we lost track of thought, so we just did 21. Okay, so 23, you can see 23 here. And 23, notice the exponent, right? 365, right? And so looking at the problems to make sure we're clear about that. So again, they don't give you the exponent. They give you the time in years. And so if we're going to get our percentage based upon days, the exponent needs to be based on days, right? So that's why this is 365. Okay, and then 25. 25, you guys don't have to worry about. It got cut off. So again, I didn't catch that. So it got cut off right here. So one less problem you guys have to worry about. How about that? All right, now 26. And for this bottom part here, you're just computing the interest for the top, and on the bottom, you're finding the new value, which was just like 15 through 19. Okay, so just to make sure you're clear about that. So here we want to do the simple interest. So that means there's no exponent. So 250, let me let Rose back in. Okay, so Rose is back in. So 250 times 0.02 times 4. You do not need a growth factor with simple interest. The percentage is always based upon years. Very rarely is that different, okay? All right, so if you want to see that one, so 26 you can see. And then this is the interest. If you want to find the total amount you owe, you add to the 250. So you're just looking for the interest. So you're just looking for the right side of that plus. Okay? And then now 37, which was the one down here. Now that 37 was a tricky one. So I would have gone over that anyway, but I'm glad you asked. And the reason it's tricky is because what they gave you is time. All right, so we can see the percentage per year, 1.5. We want to make it quarterly, so we divide by 4. All right, but they don't give us the number of quarters, they give us the number of months. So once we have our percent per quarter, the exponent has to be the number of quarters. So 18 is not the exponent, it's the number of months. Well, if you got 12 months in a year, that means every 3 months is a quarter. So divide 18 by 3. So 18 divided by 3 is the number of quarters in 18 months. Okay. All right. Well, 29. Somebody just throwing that out at me. So here it's just really 8,220 times 0.03 times 8. That's it. All right. Again, simple interest is no growth factor. So right over here, 0.3 times 8 times 8,020. There's no exponent. Okay? I'll wait a couple seconds. One more thing I want to point out, though. So when you go up here, notice you're just comparing these two. So here, when you do 44 and 45, that is based upon comparing simple interest to compound interest. All right. Which loan results in less interest due? So for 44 and 45, you're finding the interest, right?
Why?
With simple interest, it gets you the interest. With compound interest, it gets you the total value. So you got to subtract to get the interest, right? So that's why I'm subtracting 1,000 here, just in case that's an issue. Okie dokie. All right, well, let's look at what we're going to look at today. I'm going to skip this because it's just not relevant as much. When we create functions, there's a number of ways we can do that, and we've been doing that. You can add them, subtract them, divide them. But a lot of times we create what's called a composition by replacing the input variable with a function expression. So we'll have two functions, f and g. If we put the g into the domain of the f function, that's what this means. Okay? The problem here is that's a lot of parentheses, right? And so humans, being what we are, we like to abbreviate. We use this circle. Instead of writing all these parentheses, we use this circle. Okay? So this little circle does not mean multiplication. This little circle means we're going to create a new function. We're going to compose a new function by replacing the domain of the f with the g function. That's what that means. Okay? And so this kind of describes how you do that. We're also going to get the domain stuff. The homework I'm giving you doesn't ask for that, but I need to be thorough, so I'm going to go about and do that. Okay? All right, I'm going to write an example on my whiteboard, and we'll just do one example since it's, I think, really all you guys need. All right, so we're going to have two functions, and I'm just leaving the screen share momentarily in case some of y'all need to digest it or write it down. All right, so we've got two functions. One is going to be a rational function, and the other is going to be a radical square root function. Okay, I'm going to stop the screen share. Let me bring my cursor, and we go stop share. And you can see we have our function. All right, so a rational function and a radical function. Now, if we look at the domains of these separately, here the domain x can't be -1. Here the domain x has got to be greater than or equal to 2, right? Otherwise, we'll get the square root of a negative. Another thing here is this is plus. There's no plus or minus because we did not take the square root of both sides. This was given to us. So when you're giving a function with a radical notation, don't assume plus or minus unless it puts plus or minus there. You only have to do plus or minus always if you take the square root of both sides, because then you're using the square root as an operation in the process of solving a problem. Okay, so let's do g of h. That's what people call this, g of h. Right? Notice I'm not putting the little parentheses x here. Right? And what does this mean? This means into the g function, we're going to replace the domain of the g function with the h function. And then I'm just using brackets here to make it a little more visual. Okay? So we're going to find this composite. Then we're going to get the domain. Okay? So we're going to find this composite. So we're going to replace the x in the g function with the h function. So I'm going to replace x with the square root of x minus 2. Okay, so this is now our composite function. This is called g of h. Okay, now when you get the domains, you got to get two domains. The domain of the input function, because if it crashes, then you won't be able to have a domain value for the g. So you need to find the domain of the input function, and then you need to find the domain of the composite function. So there's two ways you can have invalid values. The input of, and then the composite function. Okay, well, what's the problem here? Well, we said that earlier. The domain here would be, let me get my blue pen. The domain for the h function would be x has got to be greater than or equal to 2. Well, what about here? Well, we got a little bit more of a challenge here, because not only does x got to be greater than or equal to 2, but we also need to make sure we don't get division by 0. So with this one, the square root of x minus 2 cannot be -1. All right, now to take the entire domain statement, we pick which one of these is most inclusive. Okay, well, this can't happen, because again, it wasn't plus or minus. So the square root of x minus 2 is always going to be positive. So that can't happen. All right, so then that means that's the domain. The domain of this entire composite function is going to only be valid for values of x greater than or equal to 2. Okay? All right, now let's switch that around. So now let's do the h of g. Okay, and again, this means we're going to put g into the domain of the h function. This does not mean h times g. It's not a dot. It's a little circle. Okay, so now we're going to go ahead and into the h function, we're going to replace the x with g. All right, so this x is going to be replaced with g. So we're going to replace that x with 1 over x plus 1. Okay. Now, yesterday I overlooked something with this and I corrected it, so I don't know if y'all caught that, but for y'all, we'll do this correctly. I just forgot about when you have a rational, you'll see. So anyway, we can simplify this. We'll worry about that in a minute. But we got two domains here. The domain of the input function. Well, the input was g. X cannot be -1. Okay, so the domain of the input function, x cannot be -1. All right, now the domain of the composite. Well, in addition to x can't be equal to -1, this expression has got to be greater than or equal to 0. Okay, so now we'll go ahead and simplify that. So I'm getting the common denominator. All right, so then we want to have this expression after simplification greater than or equal to 0. All right, now remember, this is a rational function. Now, yesterday I forgot about that, and I just went ahead. What I did yesterday is I said, well, this is what we're solving. And I said, okay, let's do reciprocal. And right, and I think I did something like this, and then something like that, and then I solved this. And so this will lose solutions. So you can't do this that way. Anytime you have a rational function, you have to get a big fraction compared to 0, and then do the numerator zeros and denominator zeros. And I'm going to point out to you, that's why I wanted to show you this. So this is not correct. This is going to be correct. Okay, so let's go ahead and simplify that. All right, so this is going to become -2x minus 2, right? Okay, so 1 minus 2, so -1 minus 2x over x plus 1 greater than or equal to 0. Okay, I'm just making sure. All right, now I'm going to do a little trick because I hate negatives. I want to be positive, right? Okay, so I'm going to multiply both sides by -1, right? And when we do that, we got to reverse the symbol. So what we're really looking for here Again, this is going to make this a lot easier. That's what we're solving. And now that there's no negatives, let me make that a little easier for y'all to see. Now that there's no negatives, we don't have to have too much detail. Okay, so now we got to do two things. The numerator zeros, denominator zeros, test points on the number line. Because remember, this is a rational function. If you want to make a graph of that and see where it's below the x-axis, you could do it that way too. All right, so numerator zeros, denominator zeros. All right, numerator zeros equals 0, subtract 1, divide by 2. So -1/2. Well, that's what we got over here, right? If you subtract 1. Okay, and then the denominator. Well, denominator 0, -1. That's come from the vertical asymptote, so that's why I put a little line. All right, so now test points on the number line. All right, so 0, -0.8, and -4. Okay, so if you put 0 in here, you're going to get 1 over 1. Right, so it's going to be positive when you're greater than -1/2. Okay, -4. Okay, if you put -4 in here, you're going to get 1 plus -8 over -4 plus 1. Negative over negative. Again, positive, so it's positive over here. So logically, this is probably the solution, right? But let's go ahead and test that. So -0.8. If you put -0.8 in here, 2 times -0.8 is -1.6 plus 1, negative. -0.8 plus 1, positive. So it's got to be above the -1 for you to get a negative over a negative here. Right? And that's why this wouldn't have worked. You would have lost the left side of the solution. Right? It's not less than -1/2 forever. It has to stop at -1. So the domain, finally, is, now I'm going to erase this or equal to, because remember that came from the denominator, so it can't equal -1. We already had that over here when we established the domain of the g function. Okay, so that's the final domain. Okay, I don't think you guys have something as involved as this, but it's good to know how to do this. Okay, does anybody have any questions about anything? I'll go ahead and unmute y'all just in case y'all want to be verbal. That's cool. A lot of y'all muting yourselves. It's all good. Okay, so the normal homework I would give for chapter 5, I'm kind of downsizing, as this medium of instruction isn't the best, right? So I don't feel that it's fair to put too much expectation on y'all. Okay, so I posted the homework, and it's basically just some of the textbook that I would have assigned, but I'm just going to give y'all PDFs because it's kind of hard for me to predict what a fair expectation is. So I'd rather do this day by day. Okay, but basically we're doing chapter 5. All right. Okay, everybody good? You're welcome. Okay, y'all hang in there and things will be okay, all right? Just participate, you'll be good. You're welcome. You're welcome, Mila. Okay, I'm gonna go ahead and get out of here. You're welcome, you're welcome. Well, y'all have a great day. I'll see y'all on, what, Friday?